Hey guys, it's Mr. Lowry here. I wanted to take a little bit of time to run through this deductive reasoning syllogism and detachment assignment. This was from last week, but it was due yesterday, and so I just got through grading some of these. And overall, I'm happy. I'm impressed with you guys being able to do your homework on your own and doing your best, even though this is kind of a tricky situation. But this one, there was a few misconceptions, and I wanted to walk through this. It's kind of hard to do distance style, but I'm going to walk through some of these examples with you, just so I can explain a little bit better about syllogism and detachment. So syllogism, here you'll notice it says transitive property, right? So it's kind of like our transitive property of equality. In syllogism, you're going to have three different statements, though. Okay, you're going to have a P implies Q, and then a Q implies R. So there's going to be like three different pieces, a P, a Q, and an R. And you want to see them in this order. You want to see the P go to Q, and the Q, and then the Q go to R. So the idea is the conclusion of the first statement should start the second statement. It should be the hypothesis of the second statement. So that order is really important. If these are reversed, it's not a valid syllogism anymore. And once you have the P implies Q and Q implies R, you skip over Q and you just go from P to R. Okay, so let's map this out a little bit. I saw a few people doing this on your assignment, like little notes, which is really, really cool. So let's take a look. So Jenna is in Mrs. Jones's class. Okay, so that's kind of like a P implies Q. Now we talked about how to write these in if-then form. So if we're talking about Jenna, then that person that we're talking about is in Mrs. Jones' class. Okay, so P is basically the person we're talking about is Jenna, and Q is in Mrs. Jones' class. Okay, notice the very next statement starts with Mrs. Jones' class, right? It starts with Q. Okay, so the last statement then should be, Mrs. Jones' class, and then goes to the library. So this in the library thing is a completely different idea. This is R now. So if we're talking about Jenna, she's in Mrs. Jones's class. If we're talking about Mrs. Jones's class, they're in the library, right? So Jenna, right, that's the P, is going to be in the library, Q, right? So that's what a syllogism looks like. Okay, it looks like a transitive property, basically. But the order is really, really important. If we get some things in the wrong order, or some things are mixed up, it's no longer a valid syllogism. So on your homework, you saw some things that looked a lot like syllogism, but weren't because the second statement was switched or something like that. Okay, so when we say, okay, Jenna's going to be P, any other time we see Jenna, that's going to still be P. Right? If we say Mrs. Jones' class is Q, okay, any other time we see Mrs. Jones' class, we're going to label that Q. Right? We get this in the library thing, that's a new thing, so we label it R, and we see the pattern. And what we notice is we have P going to Q, Q going to R, and then P going to R. Right? That's kind of the structure there. Okay, let's look at one more of these, and then we'll look at some example, or we'll look at detachment, and then we'll do some examples. Okay, so if Molly arrives at school at 8, so this whole thing right here is P, right? The hypothesis of the first statement. Then she will get help in math. Okay, so this is Q. Any other time we see Molly arriving at school at 8, we're going to call that P. Any other time we see Molly getting help with math or somebody getting help with math, we're going to call that Q. Okay, so Molly getting help with math, that's Q, right? Okay, then she will pass her math test. So this is a brand new statement we haven't seen before. We better label this as a new statement R. Okay, so P to Q, P implies Q, Q implies R, right? And then we start with Molly arriving at school at 8 a.m. again, which was P, right? We started out with P. Okay, and then we passed her math test again. Okay, that's R, right? We labeled that as R, so we have P going to R. So P implies Q, Q implies R, therefore P implies R. And that's syllogism. Okay. All right, let's look at detachment really quick. Detachment is kind of interesting. What you're going to see is you're going to see P implies Q, and then the very next thing you're going to see is like a specific example of P being true, and then you're going to say, therefore, Q has to be true for that example. So P implies Q, then you're going to see a specific example with P being true, and then you're going to have to say the conclusion is therefore Q is true in that example. Okay, so that's the structure of a detachment. P implies Q, you see a specific example of P, and then your conclusion is that whatever Q was for that specific example must be true. So let's take a look. All men are mortal, right? So if man, then mortal. If somebody we're talking about is a man or woman, I guess we could say here, then they're going to be mortal, right? So if P, then Q. The next thing we see is Harold is a man. Well, that goes back to this guy, right? We're talking about somebody being in this group, or we're talking about P being true. So we're not going to label this as a new letter. This is just a P, right? It's just some if man, right? Harold is man. So P is being true here. And then we say, therefore, Harold is mortal. So therefore, in this specific example, that man that we're talking about is mortal. Right? So all men are mortal. This is the general statement. This is a specific statement. And remember, when we're talking about deductive reasoning, it goes from generals to specific. So this is a general statement, and then we see basically a specific version of this. That's a detachment. Okay, let's look at another one. Every time I take a class in math, I ace it. So P, right, Q. Okay, I am taking a math test today. Okay, so today is a specific example of a time when I take a math test. Okay, and then the conclusion is then today on this specific test I'm taking today, I will ace this test. So again, P and a Q, right? So it goes PQ, PQ. The first one is general, the second one is specific. Again, syllogism goes PQ, QR, PR. Okay. So the order is super important. The labeling is super important. Let's go through the example problems, or let's go through the problems from the homework and see if we can figure out why these are the way they are. Okay. All right. Another thing that a lot of people missed is it says determine whether a valid conclusion can be reached using the law of syllogism or the law of detachment. If so, state what law was used. If not, write invalid. So some people wrote valid, invalid, valid, invalid. Well, if it's valid, you got to tell me which one you're using, okay? So let's take a look. If two angles are adjacent, okay? That's a P. Then they have a common vertex. Okay? P implies Q, right? They actually both start out like that. Whether it's going to be a detachment or syllogism, they both start out with P implies Q. So that's not too surprising. Okay? Angle 1 and angle 2 are adjacent. Okay, hold on a second. Adjacent was P. Two angles being adjacent was P. So this right here is another P. It's just a specific version of P. Right? We're saying, okay, well, here's two angles that are adjacent. Okay, well, then those two angles better have a common vertex. Okay, so notice it's a P to a Q general and then a P to a Q specific. That's a detachment. So we're not just going to say valid. It is valid, but it's valid because of the law of detachment. Okay. Let's look at number 2. If a student attends UCAS, okay, there's a P, then that student has a UVID number. Okay, let's make it wavy to match the other one. Okay, Q. And sorry, I know my P's and Q's are getting overlapped. Okay, now it says Jim attends UCAS. But wait, a student attending UCAS was P. So Jim attending UCAS is just a specific example of a P being true, right? This is general in general. Now we're going to a specific case. Jim is a student at UCAS. Okay, well then Jim has to have a valid UVID, right? That's a Q. So this is another detachment. Okay, next one, all dancers like running. So we have to kind of turn this into a if-then, right? So if dancer, then like running. If the person we're talking about is a dancer, then they have to like running. So if dancer, then they like running. Okay? And then what we see is Jeff likes running. Well, what is somebody liking running? That's a Q, right? So this is a specific example of Q. That doesn't really match our detachment pattern, right? If it was detachment, we would see Jeff as like a dancer, like Jeff is a dancer. And then it would say, therefore, Jeff likes running. So this is not detachment, right? This looks like another statement. Actually, sorry, it looks like a Q, right? It's a specific example of Q. So it maybe could potentially be a syllogism because it's starting with Q. And then this whole thing over here, like this is kind of another statement. So we're not chaining anything together, though. We're not saying, like, all dancers like running, Jeff likes running, Jeff goes to UClass, therefore all dancers go to UCAS. Like, we're not chaining it together. It kind of looks, it's definitely not a detachment because this is a specific example of Q being true. Next, we would see if it was syllogism, we'd see another if-then, right? So we kind of don't really see that here, and then we don't chain the first piece to the last piece. This doesn't really make a whole lot of sense. This one's invalid, which I think a lot of people got. Okay. All right. Let's look at number 4. Okay. If two angles are adjacent, they have a common vertex. So if P, then Q. All right. Let's see what we have next. Angle 3 and angle 4 have a common vertex. This is a specific example, but what is it a specific example of? It's a specific example of two things having a common vertex. This is a Q right here. This is a specific example of Q being true. And they're saying, well, if that specific example of Q being true, if that specific example of Q is true, then this same specific example of P has to be true. But we know that not every converse is true. Essentially what they did is they gave me a statement and then they switched the end. They gave me a converse statement at the end, a specific example of a converse statement, which isn't necessarily true. It could be true in some cases, but this is not valid logic. So you could get lucky and maybe it's true in your specific case, but this is going to be invalid. It looks like it could be a detachment because we were talking about a general statement and then a specific statement. But the reason why this is not detachment is because the second statement, the specific example, is in the wrong order. We want to see a specific example of P followed by a specific example of Q. And we don't. We see the opposite with a converse. Okay, let's take a look at number 5. If you like pizza with everything, then you'll like Cardo's pizza. Okay, so if you like pizza with everything, then you'll like Cardo's pizza. Okay? If you like Cardo's pizza, then you are a pizza connoisseur. So remember, this is another if-then statement. It starts with if you like pizza with everything, then you'll like Cardo's. The next one is an if statement that starts with Cardo's. So if Q, right, then another statement, pizza connoisseur. That's R. We'll box that one. Or circle that one. Okay, so if P then Q, if Q then R, so the last statement should be chaining P together with R and skipping the middle part. So if you like pizza with everything, sure enough, that's P, right? Pizza with everything is P. Then you are a pizza connoisseur, well, that was R. Okay, so this is a syllogism, basically like that transitive property, right? The end of the first statement is the beginning of the second statement, and then the conclusion is the very first statement is tied with the last conclusion. The hypothesis of the first is tied to the conclusion of the last one. That's a syllogism there. Now, you may think about this and say, I don't think this is true. Like, if you like pizza with everything and you like Cardo's pizza, like, maybe that's not a true statement. Okay. We talked a little bit about valid and invalid versus true and untrue, or sound and not sound. If all these statements were true, right, you'd say, okay, the logic is valid. Now, whether you think it's a sound argument depends on whether you think this premise is true, right? If you like pizza with everything and you like Cardo's pizza, you might say, well, I don't agree with that. I don't think that's true. Well, the argument here is still a valid argument, whether it's sound or not. So this is still valid. It's still syllogism. You could argue that it's not a sound argument because the premise isn't true, but that's kind of a different story there. So this is a syllogism. Okay? All right, let's keep going. Okay, number 6. If a rectangle has 4 congruent sides, then it is a square. So let's be really careful with the if and then. Okay, so if a rectangle has 4 congruent sides, not just if the rectangle has 4 congruent sides, right, then it is a square. So if P, then Q. Okay, then the next statement starts with square, right? If it's a square, then it has diagonals that are perpendicular. So I added kind of the if and then, but same idea. So this is if Q, if square, then R, the diagonals are perpendicular, right? So again, P is that a rectangle has 4 congruent sides. Q is that it's a square. Q is that it's a square. R is the diagonals are perpendicular. Okay, so if this looks like it's stacking up to be a syllogism, but if that's the case, it should go from P to R. So that would look something like this. If a rectangle has 4 congruent sides, then the diagonals are perpendicular. But notice this isn't P. It's kind of part of P, but it's not P. P is if a rectangle has 4 congruent sides. This is just some rectangle. Okay, so this is not P. This right here is still Q. So it kind of looks like it's going P to Q, Q to R, P to R. Sorry, this is R. It kind of looks like it's going from P to R. So this looks very, very much like a syllogism, but this is not P. Right? P is that the rectangle has 4 congruent sides. So we're missing a little piece of information. It's almost a syllogism, but this is going to be invalid. Okay? All right, number 7, perpendicular lines intersect. So if perpendicular, then intersect. Right? So here's P, here's Q. Okay? Then we jump to some specific lines. So this is a general P and Q. Then we go to, okay, here's some specific lines that are perpendicular. So this is another P. We're still talking about perpendicular lines. We're just talking about M and N specifically. Okay, well then those two lines, M and N that we're talking about, better intersect. Right? So it's a general statement, P then Q, and then a specific version of that same statement. That's a detachment. Okay, so if you kind of, you can see that I have a bunch of scribbles on here, right? It's all scribbled up and marked up and crossed out and things like that, right? That's something that you can do when you're trying to figure out what these are, because the order, the structure of the statements is important in logic. So label your P's, label your Q's, label your R's, figure out what's going on. I kind of like to, you'll notice, I like to underline my P's. I kind of wavy underline my Q's, and then if I have an R, I circle it so that I can kind of match them up that way. I've also seen people do it with color coding, which is really cool. But yeah, some of these are kind of tricky. Some of these are kind of obviously funky, like number 3 is kind of funky. Doesn't seem like there's a chain of reasoning there at all. Number 1 and number 2 are pretty classic examples of detachment, but 4 is a little tricky, right? 4 looks a lot like a detachment, but it's not, because again the order is reversed, so that structure is important. 5 is also a little tricky. It's definitely a valid syllogism, but you might argue that that statement itself is not sound because you maybe disagree with the premise to begin with, but it's still a valid argument, assuming the statement or the arguments are true. The statements are true. 6 again looks kind of like a syllogism as well, but you don't have the full P statement here, which is going to throw you off. This whole P statement was rectangle has 4 congruent sides. And then 7, again, is detachment. So be careful, look at the structure. We'll probably do another assignment like this, just because I think we need a little bit more practice on these. But I hope that helps. You can kind of run through this again and look at those reasoning. The last one I'm not going to go through because I think most people are good with that, but when we take a statement, I'll kind of get you started. If rolling stone, then gathers no moss, right? You have to kind of write it in if-then form. So the hypothesis is like, if you have something that's a rolling stone, or if you have a rolling stone, then that stone gathers no moss. And then you can, converse is flipping it this way, inverse is negating both of them, and then contrapositive is negating and flipping. So that's a little bit of a blast from the past, a little bit of a review. But this is the stuff that I really want to focus on, because I saw typically like a little bit lower scores on the attendance quiz for this, and then a little bit lower on the homework. So I'm probably going to add, I actually already added a point to that attendance quiz you guys took, and I'll probably add a point to the homework as well. So if you got a little bit lower, don't worry. We'll bump it up a little bit and give you guys another chance to practice this concept. Thanks for watching, and I hope that helped.